Hello team, in this lesson we are going to start learning relational databases. We are going to start from understanding of basic concepts and gradually we will move to more complicated topics. We are going to start our lesson with learning such basic terms as table, entity, attribute, tuple, record, etc. Separate focus I will put on the differences between database and schema, because very often my students ask me, what is schema and how it is different from database? After that, we are going to learn such important concept as primary key. I will share with you different examples and I will help you to understand the difference between simple and compound key, natural and surrogate key. Also, you will learn what alternate key is. To understand relationships in databases, we need to learn what foreign key is. And once we learn all these terms, we'll start learning relationships in relational databases. You are going to understand what types of relationship we have and how they are different from each other. Let's start our lesson. Before we dive deeper into the details of relational databases, let's learn some basic terms that we are going to use during today's lesson and in future lessons. Let's go over each term one by one. Database. We use this term usually to refer to a set of tables with some data in them. Is that clear? I believe there is one more question. What are tables? Table is a matrix with data of the specified format. In table you have rows and columns. Each column has name. Also each column has data type. We can specify what kind of data will be stored in this column. Tuple. In relational databases, we use this term to describe one record of data. Okay, so what is a record? Record is one row in table. Let's continue with other terms that we need to be familiar with. Entity. An entity is a distinguishable real-world object that exists. An object should not be considered as an entity until it can be easily identified from all other objects of the real world. In other simple words, if you can't identify a set of characteristics that define some object in a unique way, which allows you to store data about the object, or if you are not going to retrieve data about some object, then there is no point in creating that entity in a database. Does it make sense? Attribute. Attribute is a characteristic. In a database management system, an attribute refers to a database field. Attributes describe the characteristics or properties of an entity in a database table. An entity in a database table is defined with a fixed set of attributes. For example, if we have to define a user entity, then we can define it with a set of attributes like email, name, etc. The attribute values of each user entity will define its characteristics in the table. In more simple words, attributes are columns in database tables. And each row has set of column values. Those are attributes. But this is a very simplified definition. There is also one more term that we are going to use often today in the lesson. Schema. A database schema is an abstract design that represents the storage of your data in a database. It describes both the organization of data and the relationships between tables in a given database. Sometimes you can find that people use schema and database as interchangeable terms, but this is not correct. The fundamental difference between them is that the database is an organized collection of interrelated data. And on the other hand, the schema is a logical representation or description of an entire database. Schema contains the structure of tables, attributes, their types, constraints, and how they relate to other tables. Do you feel the difference between these two terms? These are just basic terms. The rest terms we are going to learn with examples as we go. Is that clear? If yes, then let's proceed. Another important term in relational databases is a primary key. I decided to dedicate a separate slide to review the definition. So, primary key is a specific choice of minimal set of attributes, and you already know that attributes mean columns, that uniquely identify a tuple. And you already know that tuple is a synonym to row in a table. In more simple words, primary key is an attribute or unique set of attributes that can identify a specific row in a table among others. And if you would ask me to come up with even simpler definition, I would say that primary key is a unique ID. We are going to build a relationship between tables, and being more specific, we would build relationships with data in one table with data in another table. That means we need to find a way uniquely identify each row in each table to connect them between each other. That's why primary key is so important. Let's come up with duties of primary key. The first goal is to uniquely identify tuple in a database table. And the second goal is to ensure connection between tables. Is that clear? And always remember that in case of any questions, ask them. You can put your question below this video and I will be happy to answer it. But how to choose the primary key among other attributes? What rules should be applied or what are the best practices? The rule of thumb is to select the shortest possible field, if you understand what I mean, or the shortest possible combination of fields. By saying this, I pursue one goal. Primary key should be simple enough to work with. It should be atomic and shouldn't consist from multiple values inside one field. It should be unique, and achieving of this uniqueness shouldn't be a hard thing to do. I mean, it is easy to find not unique first name, and it is impossible to find the same email. That means that achieving uniqueness for email field is more simple, and it is better option to use for primary key. And obviously, primary key can't be null value. Do you understand my point? Another important classification is that primary key may be simple and compound. In short, and in simple words, simple primary key consists of the one table field. This can be an email, ID, passport number, or anything else what is unique for each row in table and fits in one field. On the other hand, compound primary key consists of two or more fields. So, the combination of these fields should be unique. For example, I have online courses, and each course has ID, that is course primary key. Also, I have students, and each student has its own unique identifier. And let's imagine that I need to store information about enrollments in my course. I have enrollment table that has compound primary key that consists of two values, namely course ID plus student ID. And the rest information in the table, like date of enrollment, price paid, discount applied, or any other possible field, can be easily connected and identified with this compound primary key. Does it make sense? To be honest, compound primary keys are less often than simple primary keys, but still, they exist. And I'm going to teach you how to create compound primary keys in a database in a separate lesson during the practice exercise. Another classification of primary key depends on its origins. Primary key may be natural or surrogate. Surrogate primary key is also called synthetic sometimes. In simple words, the natural primary key is a field that stores useful information. For example, passport number may be unique for a person, but this is also value that contains information related to a specific person. This is real data that occurred naturally in this record. The same situation with email. Email may be considered as natural primary key. Natural keys have one logical advantage in my opinion. It sounds like this. Easy to search. Since natural key contains some valuable information, it is easy for you to understand this information. For example, it will be hard to remember sequence number for each user to search user by its ID, but instead it will be easier to memorize user email and search user by its email. Natural primary keys have some disadvantages though. The most important are: take more memory to store rather than surrogate key. This means that you would require more memory to store the data, and also this means that join requests on multiple tables may take more time, because usually natural keys are strings but not integers, and it takes time to compare strings. Requires cascading update in case of changing. Imagine that you use email as a primary key, and user decided to change email. Shall we forbid him to do so? Of course not. He changes email. After that, we have to update email everywhere, where we used his primary key to build relationships, basically in other tables. Definitely, this operation will take some time, depending on number of changes that we have to make. But why should we do these cascading changes if we could avoid doing them at all? And one more problem that you might face with while using natural key. There might be cases when you just don't have all necessary information all the time. Imagine that in your application, you also support registration via phone number. User can choose whether he or she wants to use phone number or email for authorization. And what shall we do in this case? It is hard to answer. You would have to come up with some email that you don't have in order to fill out the primary key. And what will happen when you start sending newsletter? You are going to send an email to the false address. Well, do you see what problems may appear? To address all issues mentioned above, you can just use surrogate key. On the contrary to natural keys, surrogate key doesn't have natural relationship with the rest data in the record. That's why, no matter how record will change, your surrogate key will stay the same, because its only goal is to identify record in the table. That's it, and nothing more. Usually, this is integer value that is incremented with each new row, and you are not bothered with cascading update or thinking about any false value. I recommend you to use surrogate keys, but this will be only up to you. Summarizing all above, let's come up with advantages of surrogate keys. Surrogate key has no any business-related information built in it. This makes things easier. We shouldn't worry about updating it in all related tables, performing cascading operations in case some business-related information from primary key has been changed. Also, this type of keys takes less memory, because usually we use integer type for surrogate keys, and this is only 4 bytes. Join requests on different tables also completed faster. Usually there are no reasons to change surrogate key, because it is just an identifier. Thus, there is no need in cascading update of the value in all related tables. And the only drawback that I see in using surrogate integer key is that it can limit the number of rows in a table, because at the end of the day, we have limited amount of memory reserved for data of integer type. That is 4 bytes only. But on the other hand, you can use unsigned integer value. This gives you opportunity to use one more bit to store additional information, and in total you can create more than 4 billion rows. And believe me, if you have more than 4 billion records in your table, you are going to have a lot of other problems besides limit of integer value. And if you have 4 billion users registered in your app, you have enough resources to apply workaround for this issue. One of the solutions maybe is to create table with big int type for primary key. This data type uses 8 bytes to store information, which should be enough. And after that you can copy and paste rows from one table to another and update the last ID value for auto increment. In order you can proceed adding new IDs for new records. Don't worry, I am going to show you how to do this on practice in the following lessons. We already know what primary key is and learned different classifications of primary keys. Now let me explain you what alternate key is. They are also called sometimes secondary keys. Alternate keys are those candidate keys which are not the primary key. Since there is only one primary key for a table, other fields that are also unique and can be used for tuple identification are called alternate keys. For example, imagine that you have a table with users, and you decided to use surrogate primary key. But you also have another column that contains only unique values. It can be a column with emails, for example. Indeed, it is impossible that two users will have the same email in the system. But database administrator decided to use ID as a primary key. We applied unique restriction to email column and still can use it to extract user when needed. But this attribute may be considered as an alternate key. Is that clear? Now, let's learn another important term. Let me explain what foreign key is. Foreign key is an attribute which is primary key in its parent table, but is included as an attribute in another table, with the goal to establish connection between entities. You already know that in relational database we may have different tables, and tables will be connected with each other to avoid data duplication and to ensure the most efficient and consistent data storage. Literally in a minute you are going to see examples how relationships between different tables are established. So now you know what primary key and foreign key is. That means we can learn type of relationships and understand technical side of establishing connections between tables. First of all, let's understand what relationship is. There is a definition from relational database theory that was defined by Edgar Frank Codd, inventor of relational model for database management. But instead of reading that definition, I'm going to explain you what relationship is in simple words. Relationship in a relational database management system is an association of records from two or more tables. Let me also explain relationship on example from real life. User has a car. This is a relationship between user and car. And depending on the number of objects from each side of this relationship, there are different types of relationship. Is that clear? In a relational database, there are three types of relationships. They are one-to-many, that is when one user may have many cars. Many-to-many, one user may have a lot of cars, and one car may be owned by two users, by two co-owners. And one-to-one. This is a relationship when one user can own one car only. And now I'd like you to understand each of these relationship types one by one in details. We'll try to understand it logically first, and after that I will provide technical explanation on how this is implemented on database level. One-to-many means that one object from one table may be related to many objects from another table. In our particular example with user and car, we can apply one-to-many relationship in the next way. One user may own multiple cars, but each car has only one user. This is called one-to-many relationship. One user owning many cars. Does it make sense? If you understood it logically, let's learn how this is implemented on database level. Each relationship is implemented by migration of primary key from parent table into direction of another table. The field that we received after this migration is called foreign key. In this example, we have table user and table car. We add new column in table car that is called user ID. This will be a column that stores foreign key, and for each car of specific user, we put his ID. And that's it. We successfully established relationship. Now you can query these two tables together. For example, your query may sound like this. Return me car manufacturer of each car that belongs to the user with ID 1 and user email. And you have enough information to map records from two tables between each other. Do you understand? In our SQL lesson, I will teach you how to create SQL queries to retrieve this kind of information. but is it clear for you at least on the high level? Remember, understanding the concept is much more important rather than understanding of detailed query, because syntax of SQL is something you can always learn, and something what you can always find in the internet. But deep understanding, that is something what belongs only to you, and can't be found in the internet. So, press a pause for a minute if needed to understand this. Once you feel sure that you understood this, let's proceed. On the diagram, we usually mark this relationship with asterisk and 1 digit. Asterisk stands for many, and 1 stands for 1. Again, 1 user and many cars. Each car has only 1 user. One more thing. In case you are going to use object relational mapping framework in your programming language, you may find that sometimes there is a difference between one-to-many and many-to-one relationship. Basically, these are the same relationship types, but the only difference in what is the ratio in the current object between related other objects. For example, in the same case, relationship will be named one-to-many in user entity, and it will be many-to-one in car entity. Do you feel the difference? That's great. Let's move on. And the next relationship that we are going to review today is many-to-many. This kind of relationship defines the situation when one record from one table may be connected with many records from another table, and one record from another table may be connected with many records from the first table. I can say that many-to-many relationship, it is also humans naming. Technically, this is just two one-to-many relationships, implemented in two directions. Does it make sense? Let's try to understand how to implement this. Imagine that we have students and different courses. Each student may enroll in multiple courses, and basically each course may have multiple students. We have bidirectional one-to-many relationship between these two tables, or in other words, many-to-many. In this case, we can't just put foreign key into tables, because we need to build many relationships on one side and many relationships for each record on another side. So, technically, this is impossible to do with two tables only. That's why, to organize many-to-many relationships between two tables, we need to create the third table. The third table will contain foreign keys from one and the second tables, and will map them between each other. In this particular case, if student with ID 1 enrolled in some course, we map IDs of course and student in the third table. And if this course has also students with ID 2 and 3, we also specify this in the table. Here we have compound primary key. Combination of these two fields has to be unique in each tuple. Regarding naming convention for such tables, it depends on the final purpose of this table. If we just want to establish connection between two entities, then we can use entity names and a verb that describes connection between them. In this case, we can name this table student has course, or even shorter, student course. In case we would add another business-related info in each tuple, like date of enrollment, price, information about discounts, and in case we are going to operate with this entity as with the separate one, in this case we can give some business valuable name to this table. For example, enrollment. Is that clear? And we have one more type of relationship to discuss. I am talking about one-to-one relationship. This is the rarest type of relationship. To be honest, based on my experience, you would face with one-to-many and many-to-many relationships more often than with one-to-one. Because this type of relationship describes very specific business case, when one record in one table is related with only one record from another table. Can you think of cases like this? It is hard to do without preparation, and I can understand you. I come up with some example for this type of relationship. Imagine money transaction, and you have table with all transactions in it. And also there is transaction info table. There is more detailed information about each transaction, and it also stores sensitive information and not all users can read it. That's why there is a need to store some attributes and values in secured table. But still, there is a connection between these two tables. And each transaction is connected with only one record in transaction info table, and vice versa. Each transaction info record connected to only one transaction. To implement this connection, you can use two strategies. You can either use shared key, that means that primary key in one table is equal to primary key in another table. Or you can create join column and declare a field where primary key will be exported to another table. Both options are good in this case, because they allow you to build a relationship between two tables. I would just put a stress one more time on the fact that there are not so many cases for one-to-one relationship. Having one-to-one relationship without clear argumentation is an indicator of pure database design. That's all what I wanted to share with you in this lesson. Now, let's recap what we have learned today. In this lesson, we learned basic terms in relational databases. Now you know the difference between such terms as database and schema. We reviewed in details what primary key is. Also, we have learned different classifications of primary keys, such as single and compound, natural and surrogate. I explained you what alternate key is. After that, we learned such important concept in relational database as foreign key. And at the end of the lesson, we learned three main types of relationship. Now you know the difference between one-to-many, many-to-many, and one-to-one relationships. Thanks a lot for your attention, team. Have a great day. See you in the next lesson.